Hello and welcome everyone. We are happy we are together again. Today's lecture we are going to discuss a new topic of the power system. So get your drink and let's begin. Today's lecture we are going to discuss the fill factor and the energy conversion efficiency. And we are going to take a small exercise on the basic difference between the fill factor and the conversion efficiency of any solar cell or solar panel. So let's begin. First of all, what is the fill factor? The fill factor is basically the ratio between the maximum actual power the solar cell can produce to the highest power the solar cell is designed to handle. So, if you have a typical solar cell is designed to produce a maximum power of B maximum, depending on I MPB or maximum power point current, and the MPB or the maximum power point voltage, is going to have typical curve like this. This typical curve is basically has IMPB at this point and VMPB at this point. When we calculate the maximum power is basically the area of this square, as the maximum power is IMPB times VMPB. So the maximum power is the area of this curve. But the highest current the circuit can handle actually not the IMPB, is the I short circuit, this current. And the highest value this circuit can handle is actually the VOC or open circuit voltage. So actually the highest power the cell is designed to handle is the highest current times the highest power, or this total area. So when we divide the maximum power to the highest power this cell can handle, we're gonna get something called the fill factor. So the fill factor is basically power maximum over I short circuit times V open circuit. It's basically a representation how you can benefit from any solar cell easily. Now let's talk about what is the energy conversion efficiency. Basically, if you have a regular solar cell, this solar cell is being radiated with the sun radiation. This solar cell is going to produce electrical power through two pins. The efficiency or the conversion efficiency, similar to any efficiency, is the value of the output over the value of the input. Or, in our case, the value of the output is the output electrical power, and the input is the input solar radiation power. So, to be able to calculate the efficiency, you will need to calculate the input power and the output power. Basically, the input power can be calculated easily by using the solar radiation falling on this solar cell. So, by multiplying the solar radiation of watt per meter square times the area of the regular solar cell, we're gonna get the input power falling on this solar cell. And by calculating the output power by IMPB times VMPB, we're gonna get the value of the output power. By dividing the value of the output power by the value of the input power, we're gonna get the conversion efficiency. Okay, let's take a small exercise on this. If you have a small data sheet on the back of the solar cell you are using, like this, you can estimate from this data sheet some parameters like the value of the rated maximum power of 10 watt, and the value of the short circuit current of 0.64 ampere, and the value of the open circuit voltage of 21.6 volt. From these parameters, you can calculate easily the filling factor as power maximum by short circuit current times open circuit voltage. We're gonna get 10 by 0.64 times 21.6, which is going to equal 72.34%. So the filling factor for this solar cell or solar module is going to be 72.34. If you have a solar radiation in the area you are working on right now of 1000 watt per meter square, it will be easy to calculate input power by multiplying the solar radiation times the area of the solar panel. The area of the solar panel can be calculated easily using these dimensions. The first thing is the length, the second one is the width. Length and width. By multiplying the length and the width, we're gonna get the area. Then by multiplying the area by the solar radiation, we're gonna get the input power to this solar panel. So the input power falling on this panel at 1000 watt per meter square solar radiation is going to be about 105 watt. So the output power is 10 watt from the data sheet. By dividing the output power by the input power, 10 by 105 or 9.52%. As you can see, typically the efficiency of the solar cell around 9.52% up to 25%. But the filling factor can reach up to 75%. So there is a great difference between the filling factor and the conversion efficiency. Okay guys, that's for today. Thank you for watching. See you in the next lecture. Bye bye.